Hello, I'm going to explain the problem I and its solution. So the problem is like this. You have a slot machine that shows n wheels, and each wheel have n distinct symbols. Note that the size of the wheel is same as the number of wheels. And each wheel has a sequence of distinct symbols, and this sequence is all the same for all wheels. And what you can do is to choose a wheel and move it by any amount you want. Then, after the operation, you get the number of distinct symbols that is shown on the machine. So, let's say the wheel has symbols like 0, 1, 2, 3, 4. Yeah, as an example. Then, let's say currently the symbol shown on the wheel is 0, 3, 2, 2, 3. In that case, you get 3 from the interactive. Oh, this is the interactive problem. I forgot to mention. So this is the interactive problem, and you get 3 from the interactive. So your goal is to make some operations so that all the symbols shown are the same. Note, again, I'll emphasize that your only information you get is the number of distinct symbols on the wheels. So this is what the problem is becomes tricky. So the first step is to make the shown symbols distinct. This can be done by the following steps. So, for example, okay, let's first ignore the first wheel. And for the second wheel, let's move it one by one. And if it's distinct from the other symbols, move it by any amount. Doesn't change the number of distinct symbols, or maybe it can reduce the number of distinct symbols by 1. So if we stop it by when the number of symbols becomes a maximal, we can see that that wheel shows the distinct symbols. So in this case, for example, if we move it to like 4, the number of distinct symbols becomes 4, and like if it becomes 0, number of distinct symbols is 3, and 1 it's 4, and 2 then it's 3, and 3 then it's all 3. So let's just stop at some maximum point. So let's say 4. Then we can get 4 here. And let's do the same thing for the next wheel. And we eventually get n distinct symbols shown on the machine. Okay, let's start from this point. Now, let's assume that the first wheel shows the symbol 0. Okay, then, now let's find the wheel that shows the symbol 1. How to do that? Let's move the first wheel by 1 to make it 1. Then, for all other symbols, independently try the following. Let's move the wheel down by 1. Okay, for example, if we move the second wheel down by 1, the sequence we get is 1, 3, 1, 2, 3. In this case, the number of distinct symbols is 3, which doesn't sound good. So let's reverse the operation. So let's move the second wheel up by 1 to get it to 4. Now let's move the third wheel down by 1. Then we get 1, 4, 0, 2, 3. Now the number of distinct symbols is 5, which means that if we get 5, we can conclude that the wheel we have now moved had exactly the symbol 1, because otherwise the number of symbols shouldn't be equal to n. So we can conclude that it becomes 0. And we can also ignore the other symbols. Now, we know that the third wheel has now 0, and we know that the first wheel has 1, and we don't know the symbols of the other wheel, but we can continue this process. So let's move the first wheel now to the 2, then move the other wheel by 1, and check if which wheel had shown the symbol 2, and we notice it. Let's move on here. Now, after all the operations, we now know the permutation of symbols. So in this case, like, we will finally get the permutation of 4, 3, 0, 1, 2. Now it's easy to move the wheels to make them all the same. Okay, let's estimate the number of operations we need. From the start, to make the symbols distinct, we need at most n square operations. When the symbols are distinct, to make it to know the permutation, we need n choose 2 times 2 operations. And to make it all the same, we only need n minus 1 operations. So since this problem's constraint says n is up to 50, and we can make 10,000 operations, these are sufficient. This is the solution. Thank you.